Good morning. Today we'll discuss about problems on sample and first derivative method. The theory part we have covered in the last lecture. Now we will try to solve a simple problem on sample and first derivative method to determine the peak value of a given signal. Now, I hope that by the end of this lecture you will be able to apply this method to determine the impedance phasor. Now, before we go to the problem, let's have a quick look about the formula. Any signal, if you do have a signal of, let us suppose if we do have a signal x of t, which is a continuous signal, and it is sample. And in this case, x of t, let us suppose I represent it as x, and if it is continuous such that its derivative is available for me, and I'll take it as a sinusoidal signal. Okay. So in this case, now x maximum value of any signal is given by square root of x square plus x dash by omega whole square. X can be any signal, whether it is a voltage signal or a current signal or a power signal, whatever it might be. If it is a sinusoidal in nature, then this is the formula which you can use to determine its peak value. So that we have seen in the last class. And apart from that, we have seen that magnitude of Z impedance phasor will be having a magnitude and also an angle. Magnitude of Z is given by peak values of Vmax by Imax. Vmax is equal to square root of V square plus V dash by omega whole square, and Imax is equal to square root of I square plus I dash by omega whole square. So this is the way how we determine the magnitude of impedance, and phase angle of impedance is determined using this particular formula. This we have seen in the last lecture. Now we'll try to solve some problems on this one. Now this is the problem statement. We are supposed to determine the impedance phasor, both magnitude of Z and also angle of Z. Where the sample voltage and current signals, or these are the sample voltage and current signals which have been taken simultaneously. So here is a set of values which is available for you, and this is a set of current. So apart from this, the signal frequency has been mentioned as 50 Hz, and the sampling frequency has been mentioned as 800 Hz, right? So before we start the problem, let us reconsider what has been given for us in clear. This is the voltage signal. So 45.89, 3 samples have been given for us. I'll assume that these are continuous samples, and I also has been taken simultaneously, and these are the values. Okay, and the other one which has been given for us is frequency. This is signal frequency, so this is f0, 50 Hz. From this I can determine omega. Right, 2 pi into 50, which is equal to some 314 radians per second. Now, the other data which has been given for me is sampling frequency, 800 Hz. Right, so from this I can determine delta t, which is equal to 1 by 800. It is, I think 0.0. It is somewhere around 0.00125 seconds, right? Now, number of samples is, try to remember this formula, n is equal to fs by f0. In this case, it is 800 by 50. It is 60. Okay, try to remember this formula. But as of now, I don't need this one. I'm more concerned about this delta t by omega and my v and I. Okay. So to determine the magnitude of z or the angle of z, I do require v, v dash, I dash, omega and delta t. Right. So I do have v, I do have I do have omega here, and I do have delta t also here. Right. So these two terms I am supposed to calculate. That we will see now. So how to determine v dash? V dash is equal to v at the next instant minus v at the current instant is by delta t. Okay. So we have seen that there are so many methods, but we generally choose this forward difference method. So v is 55.89, 84.82, and this is 110.84. So how to determine v dash? The next value 84.82 minus present value 45.89 by delta t. Delta t is 0.001. Now for this case, it is 110.84 minus 84.82 by 0.000, and for this one, there is no next value, so I'll skip this one. Okay. So if I solve this one, let's try this one with a calci. So the answer is 31144, and similarly the next one is so its value is 2816. This is the value of v dash. Similarly, I can go with I and I dash also. I is 11.09, 12 and 11.09, right? So what is I dash? It is 12 minus 11.09 by 0.00125. Here it is 11.09 minus 12 by 0.00125. And here I don't have the next value, so I will omit this one. So if I get this value, it is 12 minus it is 728 and it is minus 728. So this is the way how we determine the v dash and also I dash. Now for determining the magnitude of z, or this is v max by I max, right? Or you can directly employ the formula. What is v max? Square root of v square plus v dash by omega whole square. I max is, so what is the value of v and v dash which I am supposed to consider? I am supposed to consider only one set of values. So this is my first set of values that I will be considering. Or you can choose the second set of values also. It is your choice. So normally what we generally do is nothing but we will take all the set of values and we will do the average if it is required. But as of for now, we will take one set of values here. The simultaneous current values also we will take, because to know the phasor, we do need simultaneous set of values. So this is v and this is v dash and this is I and this is I dash. So let me write these things again. So v is equal to 55.89, v dash is equal to 31144, I is equal to 11.09 and I dash is equal to 728. I have taken only for the first sample, and you know the omega value, right? Omega value is 340. So if I want magnitude of z, right, I should go with V max by I max, right? So what is V max? Square root of v square plus v dash by omega whole square. So it is equal to square root of 45.89 whole square plus 31144 by 314 whole square. Now let's see what is this value is. It is 109.286. This is Vmax. Similarly, Imax. Imax is equal to again square root of I square plus I dash by omega whole square. So what is this one? I square is 11.09 whole square plus 728 by 314 whole square. Right. It is somewhere around 11.329. This is, so what is the value of Z now? Z value is 109.286 from here, and from here Imax is 11.329. So magnitude of Z is somewhere around 9.646 ohms. This is only magnitude. Now if I want the angle of Z, it is tan inverse of, we have seen the formula, right? It is omega v by v dash minus tan inverse of omega I by I dash, right? Let's have a quick, this is the formula which we have been discussing, right? So the same formula which I have employed now. So this is tan inverse of omega is 314 into v is 45.89 by v dash is 311.44 minus tan inverse of, this is 314 into 11.09 by 758. Okay, so this is the value of angle Z. So if I solve this one, I'll get 314 into 45.89 divided by 311. Right. So it is somewhere around 24.828 degrees minus 78.19 degrees. So what is the value of this one? 53.36 degrees. So this is the value, angle value. So the final values, if we keep them again, it is Z is equal to, this is magnitude of Z, 9.646, which is an angle of minus 53.363 degrees. This is the value of impedance phasor, right? This is minus 53.36. So this is the impedance value. This is what has been asked. Determine the impedance of the set. Now I have taken for this particular reading, first set of reading. Now if you want, you can go with the second set of reading also. You will get the same value again. So this is how we determine the impedance phasor when samples of voltage and current have been given on the condition that they were taken simultaneously. Okay. So with this, I am closing the session. We will try to solve more problems in the class. I hope that you are now able to solve these type of problems and you are able to determine impedance using sample and first derivative method. Thank you.